Yo, what up, gamers? Getting started in a little bit here. Oh, I didn't turn on my lights. Look how dark it is. So moody. Yo, what up, bad cop? Grok. Grok, load up! Synacor VM, version 2012. Grok, adjust the teleporter for me. Register 8. Index at 0. Where's the other light? There it is. Grok, set the phasers to run and let the GRU eat us. There we go, take a look at this. Look at this, bad cop, you are tied for first. Can you believe it? NNBB has the opportunity to do the funniest thing ever, which is to redeem second or third. Oh, that's not the right note. Dave, I'm trying to do a dumb thing. I don't know when you've ever not done dumb things. What are you trying to do now? Start running a compiler for Synacor. So you've beaten the challenge, right? You've done 8 out of 8. So you want to write something that can compile assembly into like that binary format and then run it? So you could make your own other binaries like the one we're given? Is that what's happening here? It's so funny because I'm thinking about I need to write a disassembler for this basically. You want to compile C to it. Oh. Yeah, that's dumb. I mean, that's really cool though. So you want to be able to take C code and compile it down to the binary format that's described in the architecture specification. That's incredible. I love that idea. That's also insane. Still weird that you would work on that and not finish the bash course that I know you've been following through. Last I checked, you'd only made it through an hour of my course. There are still over 6 hours left for you to one-to-one match perfectly on your stream. All right, what's going on here? Okay, right. Every app has to tell me that I went live. I like the idea of making a compiler that goes from C into challenge.bin, because then you could decompile challenge.bin into C and then understand it. So like we could take the challenge binary file, turn it into C, and then get a nice idea of what all the subroutines are doing. Because I'm gonna have to do something like that, I think, in this next part of the challenge. You have to understand its authentication method for register 7. I say register 7, the 7th indexed one, like the 8th one. We have a way to run C in bash. Okay, now hold on. I didn't realize you were gonna be doing this in bash, because I love that idea. For some reason I thought you were going to use a different language for this. No, you're actually going to do it all in bash. Okay, you know what? Mad respect for that. Being able to, oh man, being able to like compile C in pure bash, or at least some very small subset of it, is so stupid, but it'd be really funny. Now you're using C. Okay, wait, hold on. So then what do you're using C to... Oh, I got what you're saying. Oh my god. That's so dumb. Write C code, compile it to Synacor, and then you have the Synacor VM in bash. Oh, that's so funny. That's so funny. Also, I feel bad for anyone that's used to me streaming way later, because this is pretty early compared to my normal stream time. Why is the tree not animating? It is animating. I think, I don't remember what we did. I think every 10 frames, the trees change, the lights on the tree changes colors. So I could do this. I probably should make that customizable, but if I do 0.1 here, so every second the lights on the tree will change. It is, I should probably normalize it to animate a little bit faster when the snow goes slower. Like, not be tied to each other like that, but yeah. That's how we solved it. So every 10 frames, the lights change by 1. Yo, what's up, Bobby the Beard? How you doing? Hey, I took inspiration from your streams to tackle the VM challenge in C# and just finished the teleporter part. Nice! That is awesome. Oh my god. I'm glad I could inspire you to actually like take on the challenge. That is super nice. I don't appreciate that you're further than I am, so I'm going to need you to go ahead and undo that teleporter part and wait for me to get there, okay? Rude. No, but seriously, that's awesome. Yo, congrats. That's super cool. Hey, Dave, how are you? I'm pretty good. How you doing, Franco? Nice to see you. Nice to see people joining the stream. I know I'm streaming a little bit earlier than I normally do, but yeah, we're going to have some fun. We're going to fire it in there and make some, I don't know, make some... What are we going to do? Make some valid teleport register values. I don't know how else to say it. Is there a link to buy that bash course in your YouTube details? I don't know where the link to buy the bash course is. Probably. I'll hit you with a probably. But if you do want to buy the bash course, you can just go to the website for it, which is here. Look where my mouse is, course.ysap.sh. That's the permalink if you want to buy the bash course. Otherwise, it's a free video on YouTube. You can just go watch it right now. Spent most of the day just working on the teleporter instead of working. All right, that's it. Give me your employer. I'm calling him on the phone right now. You won't believe what Bobby the Bearded was doing instead of working today. No, that's awesome, though. Heck yeah. All right. What do you say we jump into it now? I don't want to waste too much time. Let's get coding, because... what do we have? We left off yesterday or whenever I was streaming last. Was it yesterday? I don't even remember. I also started the challenge. Dude, oh my god, everyone's just doing the challenge. That's so awesome. Yeah, and then Bad Cop's over here doing and beating the challenge in Bash, so just completely blew me out of the water there. That's incredible. All right, let's get started. I don't remember exactly what we have. I think we have commands.text, which gets us all the way to the teleporter. And then we have this, which shows us all the time the registers are read and read from. Okay, that's great, but we need different logging. We have like debug info warn. I don't even really like that. I don't like that style of logging. I'd have to figure out, like, thinking out loud. I would like to be able to turn on like instruction logging or like assembly logging or something like that. Synacor Challenge 2025. I think there's still a company. You can reach out to them, see if they're interested in the, 13-year later challenge. Okay. So when I use the teleporter, it works perfectly, which is awesome. But if I were to set register 7 to 1, and then we use teleporter... Yeah, so it does something, and then a bunch of work happens there. So we could set register 7 to, I don't know, 1337, and then we can try and use teleporter. And we get the same thing. Okay. Yeah, exactly. Synacor is literally just like the company name. Yeah, it's so tied to the company. It's so funny. Yeah. One that's not, I mean, hopefully Eric learned his lesson when you start tying things to the company like that, and then you leave the company, you're like, oh man, I wish it was more generic than that. But, it is what it is. So what are we doing here? What are we doing here? I want more output. We already have too much output. I want more meaningful output. Because we have these debug things. So I can do this. Rust log equals debug. And this prints the instructions and the registers. But the instructions are kind of cool. Because like the instruction tells us what our code is doing. I was thinking about this. What's up, Matthias? Or Matthias? Matthias? I'm not sure how to pronounce your name. I'm going to go with Matthias. How you doing, man? Welcome. Welcome. Yeah, a little bit earlier today. I kind of want to change the output of this because we have too much debug stuff, I think. I'm also incredibly jealous that you just feed it inputs from the starting state every time. Oh yeah, because it's that fast. I don't have to save start. I don't have to save like actual states. Yeah, I really like that. I want different. We don't need this. There we go. I want different instruction logging. I have to think about how to do that because, like, let me explain what I mean. So if I do this, oh, when I'm doing debug, we're also going to get infos. Yeah, that makes sense. Bash, but fast. Dude, I like fast. I like... There's probably ways to speed up Bash. Like, I'd have to really dig into it, but, like, looking at, like, how arrays are implemented, there might be ways to make it faster, which would be really cool. Yeah, I would like ways to give it logging to, like, turn on different bits of logging. I would like to be able to say, like, you know, turn on the register logging or turn on breakpoints or something. Because, like, this is useful. We have all of the instructions that are run, and now we're waiting on input, so we could just say, like, you know, use teleporter, and it will go into an input loop. Okay. So I think, what is it? Set 7.1. Use teleporter. Now it'll go into a continual loop. So I think we have to figure out what this loop is doing, and we have to basically disassemble it. We have to figure out what this loop is doing, and then try and figure out how to optimize it. What I did that I liked is indent every time it does a call and outdent on... That's very smart. I forgot it basically has subroutines. Yeah, call is 17, write the address of the next instruction of the stack and jump. 18, ret, which is remove the top element from the stack. Okay, yeah, we literally have subroutines there. That's really smart. Okay, we should do that. Well, first, man, I hate this format. Let me think about this format. We have instruction, the name of the instruction, and the address. We don't even put the options or the operands. We probably should put that there. I want a more like assembly, a disassembly style output. You know, where it's like I'm trying to think. Like, what does it look like? It has like the adder, then it has the instruction like call, and then you can put the options here. Yeah. Like, I'm picturing more like something you would have in assembly. Like, we don't even technically need the address pointer, but I'm sure that's probably useful to see. So you could put like what am I thinking of? I'm thinking something like this, like address pointer, colon, well, no, the name of the thing is that. I'm basically thinking of a disassembly. I'm looking it up right now. Google, I never want to click the AI mode button. Just don't even show that to me. Like when you disassemble a C program, there's like a way that it looks. I can't find a good example of it now. I wish I just had an example of it. But yeah, it's basically just address, the name of the thing, and then the options. So yeah, I think assembly style will probably be the way to do it. We'll just make up something. What I think might be a good way of doing it, we call this everywhere. It might make sense. Yeah, maybe like GDB. Yeah. Basically like that. we could just disassemble it real quick, yeah. I'm just gonna make it up. We're just gonna make it up. Log assembly. Terrible name, but here we are. This will take a the adder. No, we know the point. We know the address that we are at. That's, oh, this is perfect. Okay. Church of Rust BS. Bro, I don't even know what that means. I think it's called the gas format. Oh my god, wait, no, it actually is, isn't it? That sounded so fake. I literally just read that. I thought you were just trolling me, but I actually think you're right, because it's the GNU assembler. Yeah, hold on. I really just thought you were lying to me. But, like, yeah. Like, we're not going to have labels, but we will have addresses, so we'll just have, like, the name. I'm thinking just, like, the name, colon that, and then we can do the indent, stuff like that. So, yeah. Log assembly. What are we going to log? The opcode will be a stir. And that's it. We'll just do this for now, and we'll just get an idea, because this will let us do it simply. It'll be the address and then the operation. Okay, so now we can just do this. So now we can just change this to self.log assembly. Okay. Probably should have just recorded that to a macro, shouldn't I have? Let's do this. Let's record this to a macro. D3T quote. Oh, don't do that. Self.log assembly. Find comma, delete to the end, insert. There we go. Do that. Close the macro. So now if we just search for debug, we should just be able to replay that macro. Didn't quite work. Why didn't that work? Not really sure. No. Let's get a macro working for this. D3T quote self.log assembly. Open this. Find comma. Close that. There we go. Close that. Cool. Jump to the next one. There we go. Yeah, this is a lot easier to reason about, I think. Oh my god, is he hacking? So true, dude. You've definitely bumped up my bash rust VM assembly mojo. Much appreciated. Yo, TCB, that's great to hear. That's awesome. I love that. That is like, that's a great thing to hear. Okay, I mean, ugly, but we can kind of make sense of that. So now, I do like Bad Cop's idea, thank you for this, of the indenting and de-indenting. So we should probably keep track of that, like how deep in the call stack we are. So like, what do we call it? Level? Sure. Call stack is probably sufficient. Just have a level here, and every time we have call, we will do ugly but sensible. Title of my next repo. Oh my god, you and Eric with your with your cover bands and your repo titles. Okay, what are we doing here? Yeah, once we do this, then we will self.level plus equal 1. Self.level minus equal 1. Okay. And then when we go to print the assembly, we'll print as many double spaces as there are levels. How do you do this in Rust? I know the printf way of doing it. I think you do like this. There's like a way to conditionally print a number of spaces. Rust format macro arbitrary spaces. Eric has cover bands. I have commit messages. Okay, that's actually baller. Is there a way to do it with like you pass in the number? Wow, what is this? Okay, get ready for this syntax. So apparently I do colon and then the width, which is self.level. W here, $sign. What is this notation? And then I have to give it the character I want to put there. Like just a space, does it matter? I don't know. We're gonna find out if it looks any good. Oh yeah. Word cloud generator for commit message. I'd be afraid to see what your commit messages looks like. That'd be kind of cool though. Okay. Okay. That's something. That is certainly something. Yo, what's up? What's up? I got hit by a camel. Thank you for the Prime subscription on Twitch, dude. What a username. Okay. So this is pretty nice to look at. Let me think. What are we doing here? We need more logging. We have log assembly and that's great, but we need to like log something else. Let's just get an idea. Okay, we log all the instructions now with none of the arguments, but we at least log them. So now we could do this. We could set register 7 to 1. Okay. Now we can use teleporter. I'm going to clear the screen, and this is going to break. Okay. So this is what it's doing. This is wild. Okay. Is this right? How deeply nested do we get here? Ew. Is there like a lot of recursion going on? Are we gonna like... How big is our stack? Okay, it doesn't seem like much though. Like, jump if true, add values, return. Okay, so that's like a pretty easy branch. Jump if true, add value, return. So we'll have to like put some logging to see if we actually like jumped or not. Actually, we can see if we jumped or not by looking at this. If we go 3 addresses past it, then we did not jump. So we know that. Unless they wanted us to jump to the place we're already going to jump to. That seems super weird. So I doubt that's the case. Push add call. Push add call. Twitch says I'm taking a break? Where does it say that? All right, so I think we have to figure out what's happening here. Also, look at this. Okay, so we got some recursion going on here. Okay, so we have to figure out what it's doing to verify the number that we gave it, to then figure out... Yeah, we have to figure out what it's doing with the number we gave it, so we can figure out why it's inefficient and we can make it faster. Oh, man. Okay. All right, we need more logging here. Okay. That doesn't work. I can't just do that. I need to format that. Is that good? That is good. Okay. Push A, and there we go. It's going to be the same thing. We remove the top element from the stack and write it into A. Okay. Okay. So now we're just getting a little bit better logging here. All right, that's pretty good. Is this Rust or Java? It's actually Java. Yeah, we're working on a Minecraft plugin right now, so pretty cool stuff. I didn't want to spoil the surprise, but yeah. So this is an unconditional jump to A. And this is a jump true. This is our jump false. Okay. I do think it's cool that Notch invented Java for Minecraft and gave it to Oracle for free. Dude, that's the truest thing I've actually ever read. So that's awesome. And dude, I do appreciate that too. Like, oh man, I remember like 2010 when that big bad company Sun Microsystems was trying to like hold Oracle back from being able to bring Solaris into the future. Like, just, I don't know. Like, Sun's great, but like, help a small company like Oracle out. Come on. Oh man. All right, what's going on? Oh, what's up in YouTube chat? I've been ignoring this Minecraft Bash plugins. I don't think so. That seems scary. Yeah, don't watch my stream if you're gonna get spoilered and you want to work on this on your own. But watch my stream because I'm vain and people should be watching me. Oh wait, these aren't gonna work. What am I doing? I didn't use a format macro. Don't you need to format? Yeah, I do. I don't know why I just stopped using the format macro. Wow, I really just... Okay, wow, I just stopped using it completely. Neato. Okay. Assign into A the sum of B and C. Should probably put the answer of this thing in there too, actually log the sum, but for now we'll just do this. Okay. I like puzzles, but disassembling Eric's custom VM to re-implement his algorithm into something faster is a bit out of my league. Nah, it's fun. It's fun. This kind of stuff is fun. So. All right. Oh, I should be putting colons here. I should also be using the format macro, huh? I guess I'm not using colons. I'm just not consistent at all. Okay. Oh my god. Okay. Oh my god, I'm a bad programmer. make sure this works. Okay, that works. Howdy, Dave. Yo, what's up, Sashi? How you doing? Welcome, welcome. When I read Strange Book, I thought sure it was going to be Fibonacci, but I was wrong. Okay. Oh, well, this will be fun. Fibonacci would be... I don't know how you go and solve that. Cache it? Oh, man. Hey, Dave, I was watching your AOC 2025 VODs a while ago and heard you mention there's no way to debug bash line by line, but you can do it with nvim dap. There's no way to debug bash line by line. I would need to watch the context around that, because, like, you can definitely do bash minus X to get debugging as you're running it, so you could do, like, step-by-step that way, technically. But there's no, like, step debugger built in. You'd have to, like, override. You'd have to trap the debug signal or something like that. So there's definitely a way to do it line by line, but there's no, like, I would just need to see context around me saying that. I don't know what nvim dap is, though. It sounds like some sort of, like, plugin for nvim. That seems a little bit excessive. You shouldn't need an editor to debug something line by line. You were talking about breakpoints back then? Yeah, I mean, I don't really even know a good way to do a breakpoint besides, like, set minus X, set plus X, or read and wait for user input. Like, there's no, like, built-in mechanism of doing that. There's no, like, GDB for bash. You just have to, you'd have to emulate it. You'd have to emulate it by trapping the debug signal or doing something like that. Wow, this looks a lot better already. Okay. This format is way better. Okay. This is looking pretty good. Okay, now we're waiting for input, so let's go ahead and set register 7 to 1, so it's not 0. And now let's use teleporter. Okay, so there's a lot of data here, but we have a lot of good stuff here. So you can see the green here, TELEP. Oh, that's me typing in teleporter. And then we have the new line that it processed. As you can see, there's in, and then it's out and out. So printed 2 outputs. So let's take a look at what's going on here. It checks if equal 10 and 10. Oh, we should put more logging around this. If 1 not equal 0. Yeah, see, I'm already thinking that this is what's happening here. We're checking. I'd have to put the register numbers here, but I'm guessing we're checking. Got 0 writing into 4. Okay. Oh my God. That's the register we're writing into. Okay. Let's look at some of these. Set. Set A to 1 if B is equal to C. But we don't know what register we're checking. That's annoying. Okay, got a lot of stuff here. Set register 7 to 1. Clear the screen. Use teleporter. Okay. Okay. Oh, I know what this is. Checking equal to 10. 10 is the ASCII code for a new line. That's what the program's doing. It's checking to see if there's a new line to know that it has finished reading all of it. So it checks that this is not it, so it goes back into a loop to read the data in. So now we get that. Check if it's equal to 10, so now we're done processing input. We're going to read from register 3, read from register 1. It needs to know that we are teleporting. So at some point it's going to register 7 read. Wow, okay, it literally does it once? That can't be right. No, okay, yeah, it does it way more than that. Why is it backwards? Yeah, jump false. Okay, so if it was set to equal to 0, we would have gone to address 5627, which is like Synacor headquarters. But instead, we got to do something else. So we're going to push 0 onto the stack. We're storing these two. We're putting register 0 and 1 onto the stack. This is it. Like, this is our code right here. I'm watching you solve this and going, how did I figure this out? I don't remember. That's really funny. You are a way different person than I am. I think didn't you stream for like 12 hours or something crazy? So like, I'd be surprised if any of that's still in your brain. What's up, Bob Null? Yeah, streaming a little bit earlier today. And so far, yeah, I think we're having fun. You know, we're trying to figure out the logic that the Synacor VM uses to validate register, the 8th register, index 7. And I think this has got to be it. We've read it. Then we jump if false. It's not false. So we haven't modified register 7. How are we using it here? It is being read. Okay, I mean, it makes sense. It is being read. Look at this. I mean, that's recursion right there. It's a lot of recursion. Holy God. Okay. So this algorithm is not efficient. Oh yeah, look at this. This one's counting up. look at this. It's reading from register 0. It's reading from, it looks like it's, okay. I'm seeing reads from register 7. Obviously, we have to check that register. I'm seeing reads from register 0 and register 1. Did I see register 2? What other registers are we reading from? Whatever math is happening here, it's reading from register 0, 1, and 7, I can see. It might be reading from more. So we have to just turn this into code. I saw a register 2 there. Yeah, so register 4 is not being used. Register 5 is not being used. 6 is not being used. 7 is being used. 0 is being used. 1 is being used. 2 is not being used. I forgot which ones I said. Let's go through the order. Register 0 is being used. 1 is being used. Zero, 1, 7. Okay. So whatever mathematical calculation is happening here, we are using 0, 1, and 7. So do I have a notes file? Notes.txt. Registers in use for teleportation validation. 0, 1, and 7. Of course we're using 7, but 0 and 1. So whatever variables we have are register variables. It's not much. Like, so hopefully whatever mathematical calculations happening here is not the end of the world. You know what I mean? Set 7 equal to 1. Use teleporter. Clear the screen. Run it. Control C. There we go. So we just need to figure out where this starts. And it's basically a jump false. How many jump falses are there? There's not many jump false. That's really good. Like right here, register 7, read, and then we do a jump false. Like this is it, right? Yeah, so you read from register 7. Let's find the first time that happens. Okay, it's not 0. So if it were 0, we would jump here, which I assume is the Synacor headquarters. We're not doing that. So instead, what we're doing is we are pushing the value from 0 onto the stack. We're pushing the value from register 1 on the stack. We are reading register 2 to push it onto the stack. So we're pushing 0, 1, and 2 on the stack. Oh, I see. We're storing register 0, 1, and 2 because we are going to set them and we are going to use them for some sort of thing. So these are we're using these registers. Okay. We add these two numbers together and store it into 2. And then we call. We call with this address. Okay, so this, whatever this address is, 1480 is our, whoa, oh my God, we might actually just need a disassembler here. It seems like address 1480 might actually be the verification function. So 1480, we read register 0, which is that. We push onto the stack. Oh, we're getting ready to recurse, aren't we? We're reading, why are we reading the rest of the registers? We're reading all the registers. Is that, I don't know. Okay. What is the mem instruction? There was wmem and rmem. What is mem? Did I just write that one wrong? Yeah. That should be rmem. It's going to be hard to figure out which registers are being used to draw the screen and do the teleport things. Yeah, but I don't think they're happening at the same time. I think that is a good point. You're right. Hold on, let me think. It does print something to the screen to let me know that an error was encountered. And then it goes into its looping thing. So I might have to go way down to actually start getting some of the logic there. Okay. Oh boy. This is quite the stack we got going on here. Hey Dave, been watching a lot of your content lately. You talked about some language you learned when you took some time off that you liked and made you feel like a beginner. Was it Rust? Yes! It is this language that I'm actually writing in now. It is this language, Rust. That was a humbling experience trying to learn Rust. It's a very difficult language to learn. It's also difficult to master. Yeah, because it does print something, doesn't it? Yeah, it prints a warning when it's like strange, whatever. Okay, so I printed the new line there. Now, what is this? These are all 107s. So this is the logic here. This is the function that we have to optimize. And then what do you do when you optimize? You just rewrite it? I don't know, I guess one thing at a time, right? Probably could read that strange book again. Okay. Is 6049 the beginning of our function? Well, it shows up a ton of times, so yeah. I would think that it is. Okay. This might be our function here. So we set register 0 to 4, register 1 to 1, and then we call our function. 4 is not equal to 0, so we're not going to jump there. 1 is not equal to 0, so we check first null checks on both of them. Then we push 4 onto the stack. We add, oh my god, we're incrementing. Okay, this is a very simple function call. Let's pull up another terminal here. Yeah, so we call the function here. And all we did before we called the function again is really simple. We just started with initial value of 4 and 1. And then we didn't jump. No, we did jump here. We jumped here because they're both non-zero. And because of that, we literally added a 1 because that's what in register 1 was there. What is that add call? This is when it doesn't jump because it is 0. I don't quite understand this. Yeah, that get value function. We need to know if it's coming from a register or not. Okay. Okay, store into register 0, the value 4 plus 32, 767. We got 4 out of register 0. And we set register 1 equal to the value we read out of 7, which is 1. Oh, wow, okay. What is this function? Where's 32,767 coming from? Because that's just 1 below the register. Is that just a clever way of decrementing it? Like we're adding the max value to an unsigned number. Are we just decrementing it? Because now this should be 0. Register 1 should be 0, yeah. Okay. Okay. Register 0 never gets explicitly set beyond that. I think it only gets modified through an add call. I don't know how we're going to turn this into code. If we have a function here, like myfunc, it'll have R0. Myfunc will be called with 4 and 1 here. So this is what I'm imagining. This is just pseudocode. We have a function called myfunc, and it has register 0 and register 1. And I guess they're technically global variables. But we just, well, whatever. We'll deal with that when we get to it. And then myfunc gets called with 4 and 1. And myfunc starts at 6049. Okay. So jump if true. If 4 is not equal to 0, so we would say if R0 is greater than, is not equal to 0, then we jump to 6057. And we're at 6049. 6057 is not that far. I guess it's just beyond this one check here. Yeah, so we don't know what happens in the other case. Okay, now we have this check here. If the one that's in 1, which is R1, is not equal to 0, then we jump to 6070. So if R1 is not equal to 0, then we will jump to 6070. Else something. So I think that's right. Yo, what's up, Yeet Boy? How you doing? Bad Cop, is this making you remember how you implemented it, or is this all just complete nonsense at this point? Oh, fair enough, fair enough. Oh, then we jump to 67 because it's not... Okay, let me think. You had to print it on paper and scribble on it? Yeah, we might have to do something like that because I'm assuming this just goes next to the function when in reality this could be nested in there. Because I think it actually technically looks like this. I mean, yeah, raw format. Jump to 6057. Now we're at 6057. We check if that's not equal. This is adder equals 6049. Okay, we're putting the addresses where we are. If we get down here, then we push onto stack. And then we add register 1. I don't understand. Hold on. Is this reading and setting the same value? I think it is. Is this just negating it? Because we're adding 32,767, but like, that's the equivalent of just making this whole thing 0. So R1 equals R1 plus 32,767 turns 1 into 0. And then it, when it gets down here, it calls 6049. Okay, so it calls itself with R0 and R1. Okay. Register 0, read 3. 3 is not equal to 0. Yeah, so now it's just register 1 is just slightly lower. Then we pushed 3 onto the stack. And then we add 1 again. It's the same thing. I don't understand what this function is doing. Yeah, right here, it's probably important. Okay. Register 0 is now 4. Register 1 is now 0. So if it's 0, it goes to 6070. Otherwise, it's going to 6062, which sets register 0 equal to register 0 plus 32767. Okay. 60, 57, 60, 60. So here is where it does something. Register 0 equals register 0 plus 32,767. Okay. And then we set, this is just an unconditional set of register 1 to whatever's in register 7. What? No, we don't need to put these here. Just my funk. Okay. We're getting some code here. Okay. Register 0 is 3. 3 is not equal to 0. Register 1 is 1. 1 is not equal to 0. We push register 0 onto the stack. We add 32767 to register 1. And then we call it again. Yeah, we already have this logic. Something really, this is mind-blowing to me. Maybe if I keep going through this process, maybe something will reveal itself to me. I don't actually know. See, register 0 is 2. Register 1 is 1. Yeah, whatever this algorithm is, it kind of sucks. Hey, this is interesting. So, okay. R0 not equal to 0. I think we need to find out what happens in the case where R0 is not equal to 0. Wait, is equal to 0. Okay. In that case, $60.54. Oh, that's where we actually start calling returns. Hey, look at that. So that's what's going on here. We set register 0 equal to, I think that's just a literal +1 to R1 plus 1. And then you return. Like we're just done. Is this inline Rust assembly? This is not even anything. This is a text file with pseudo C code from a binary in a format that I'm trying to reverse engineer using Rust. So this is where the returns actually get called. I could not tell you what this function's doing. The function's at 6049. jump here and we push it onto the stack. We push a whole bunch of stuff in the stack. When do we ever pop? Get pretty far down before we ever pop off the stack. I don't understand. What I'm trying to do right now is take this basically disassembly. I don't even like the format of it. Take this disassembly. Hold on. Take this disassembly that I have right here and turn it into some pseudocode like C or something like this pseudocode I'm writing up here. I'm trying to disassemble this into like C, and then trying to see if we can like figure out what the algorithm's trying to do. And once we figure out the algorithm's trying to do, then we could, optimize it, maybe cache it. There's only what, 32,000, 65,000 possible inputs. So if we can make it very efficient, we could just make like a lookup table or something. I don't know. I haven't figured that part out yet, but yeah. Do you want a suggestion that might help? Yes, please. I will gladly take one at this point. Yeah, what you got for me? So I think what I'm looking at is the instruction being logged. Okay, like, yeah, like here. We set register 0 to 4, register 1 to 1, and then we call our nice little function, which is address 6049. And then we run all this code. We got to figure out what that code actually means. What I'm looking at is the instruction being logged. It's also helpful for me to just look at the like sequential instructions in memory. Ah, okay. Like actually look at what, like be able to dump a disassembly. Let's say like, hey, show me 6049 and show me, like the 10 instructions after it or something. Yeah. Yeah, because I don't see any like, that's a good point. Because if I look at this, it's the instructions are like jump true, set, add, call. I don't see any WMEM or RMEM. So like the RAM should be pretty much set at that point. You're only seeing the happy path. Yeah, we're only going to see, I see what you're saying. Yeah. Yeah. Let's do that. Let's write something that could dump RAM. Let me think how I want to do this. Because we have the challenge.bin. I don't know why I decided to open it. Being able to run a binary file through a disassembler would be useful. And then, in our thing, we could dump a save state of that. I made mine dumb. It just dumps until it hits something that doesn't look like an op. Oh, okay. Interesting. It was helpful for me to do exactly what you're doing. I wrote up an instruction for instruction equivalent in Python with a dinky stack. That's what I'm thinking, yeah. I think we're going to have to write this in some sort of language, like obviously some sort of Rust implementation of it. But yeah, let's figure out how we're going to do this. Yeah, let's just write, let's do something new. Source, make dir bin, cp main into bin. I don't love that, a lot of duplicated code. We should probably abstract this out into like a VM module, but we'll worry about that after. Let's move main to dis for disassembly. So now we won't need registers. Well, let's not delete code. Let's just start doing it here. Grab the bin file. Make a new binary with the bin file. Okay. Yeah. It is kind of interesting how it's just like the VM, but worse. Wait, what do you mean? I guess we'll take a adder here, and then we'll return another adder. Set register A to the value of B. Yeah, we'll do some cleanup here. The code for the disassemblers. Yeah, it is. It's very similar, but definitely really dumb because it doesn't have to do half the stuff. Why do you have this? I figure you just made it. That's awesome. I love that. Okay. Is learning C worth it? Worth it for what? Also, Bad Cop is right. Definitely worth it. I gotta think about this. I don't know what I'm doing. I'm losing it. Hold on. We want to set register A to B. So this will be a register number. Is that what we want? This is a nightmare. I've completely lost all mental context for this. Yeah, dude, I'm locked in, man. I can't think when I'm doing this. This is just boring, tedious work. Like, this is just work that needs to get done before I can even make any meaningful progress here. Oh, this is a nightmare. What am I doing wrong here? How is there a match? What am I doing wrong? Log assembly, open parenthesis, replace with log assembly. There we go. Okay. 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 I don't even know if this is gonna work. I think I'm just, I don't know. We're hoping here. Cool, that looks right. Yeah, what's up, Frozen Fusion? How you doing? Okay. It's an adder plus equal 2. That's right. But now it probably just isn't it's probably just arbitrary data that isn't read anywhere. Is this file full of like just bad data that we're not looking at? I mean, probably, but like that's annoying. Yeah, do we just have like a black hole of just like random crap? I don't know, man. I guess instead of panicking, we could print line and then adder plus equal 1 and try again. Okay. Guessing there's just binary data stored at the end, like arbitrary data. I don't know. Whatever. Let's try this. Okay. What if you started at the line where that function call happens? Let me... We're not there yet. I only have the challenge binary that came with it. I want to write out the binary after we get to the part where we've taken the teleporter, but we haven't used the teleporter yet. So... because I assume the binary file is going to be different at this point. So I need to write out that new thing. So we need a new command. We have a set for the register. We should probably just like call it register or something. Set reg. I don't know. We need a save. And that will have a file. Command 1. And then we should write the vec of bytes to a file. Rust write vec of bytes to file. I think it's just fs write. Wow, yeah, it literally is. Okay, cool. We should probably check to see like if a file exists. I don't want to clobber a file or something. That'd be kind of annoying. But like we could just do this like because it should be fs write the file path and the self.ram. Okay. Is there no clobber in Rust? I mean, I could just stat the file. Yeah, let's let's introduce a small race condition and, you know, stat the file first. Okay, so now we can do this. Let's save this to before teleport.bin. Okay, let's quit. I don't have a quit command. All right, so now we should have a file called before teleport.bin. Hey, look at that, we do. Before teleport.bin, 59K. Are they different? MD5, before teleport, and challenge.bin. They are different. Yay! Okay, look at that. Cargo, run, bin, disassemble on before teleport.bin. There we go. And the function that we care about was in my notes, 6049. So there it is. Here is the disassembled version of that code. Oh, wow. This is cool to see. They like use that space to write the rest of the code too. Huh. Cute. This thing's programming itself. So 6049 is the function. Okay, so this is it. This is the function call. Oh my god, bad cop. Oh, thank you. Thank you. It's a lot easier to read. Oh my god. Okay, so the goal would be to turn that into a function. Let's do a I can't think of Rust right now. We're just going to do C. I'm running out of ideas. 6049.c. There we go. We have 6049.c. This is C is the language for reverse engineering a binary. It's just the right thing. You also want C? Okay, cool. I feel good now. Because like this C is just the language for this. You know what I mean? So we have a function 6049, function 6049. I have no idea what this will take. I have no idea what this will return, but that is what we're going to do here. And we will call 6049 here, function 6049. I actually don't know if you can do just 6049 on its own. I think you need a letter in front of it. I should double check. You called yours F6049. Okay, awesome. Okay, I mean, yeah, so awesome. Okay, I feel good about this. That's awesome. Yeah, function 6049. Okay, so here's what our function has to do. We have to... Are the registers... Let me think out loud. I don't actually know where to go with this yet. R0, R1, and R7, the registers, are they global? Or are we passing them as arguments? So we pass them as arguments, then we have our own stack. If we make them global, then it's probably easier to port over the assembly. Let's just make them global for now. What's a U16? uint 16 T? Is that it? Yeah. Is it an unsigned short? I don't know. uint 16 T is good enough. What is that? Is that size.h? What has uint 16 underbar T? I don't know. I think it's like sizes.h or something. Making them local is more like doing push pop. Yeah, I have to think about that. Standard int. It is, yeah, standard int. Thank you. Not .h. What am I doing? Do I just not have it on this machine? That's cool. But yeah, standard int. That's what I was thinking of. One thing I didn't consider, but I'm thinking about now. What's that? Once you write your function, you could disassemble it and compare. That's cute. Oh my god, yeah, you're right. Yeah, a lot of the instructions are very similar. Oh my god, I like that. Huh. Well, go ahead and write your C to Synacor converter. All right, 32,768 is register 0. If register 0 is not equal to 0, then we go to 6057. If register 0 is not equal to 0, then we jump. So if it is equal to 0, we don't jump. And in the case where we don't jump, then we were at 6052, which means we will add to register 0. R0 equals 32,769. That's R1 plus 1. Okay. Is that really what we do? And then we return? Okay. Okay, so if R0 is not set, then we initialize it. Or, well, if it's set to 0. Okay. Because if it's not equal to 0, then we jump to 6057, which is here. Okay. If R1 is not equal to 0, then we jump. So if it's equal to 0, then we stay here, which is 6060. Do you save the state of the registers at the point where the function is called? Yes, I can dump the registers at that point. I think in my case we had them, it was like 1 and 4 or something. But yeah, I can do a /dump in my program and get that there. So we're at 6060. So R0 equals 32,768, which is R0, plus 32,767, which is a literal value. So if we're using uint62t's, this, what does this thing do? This just, if it's a 0, it becomes the biggest number. If it's a 1, it becomes a 0. Is this just the, this is a decrement, isn't it? This is just a decrement by 1. Let's not focus on that now. We can come back to an optimize later. Let's actually port the code over. So 6060 is there. 6064 is here, where we set R1 equal to 32,775. That is register 7. 32,768 is 0 plus 7, 7. R1 equals R7. Okay. $6067 is to call. So that means we call ourselves 6049. With those new variables, we'll deal with that. 6069 is return. Okay. Okay. It is decremented by 1, useful because we don't have the sub instruction in the VM. Yeah, that's what it looked like to me. I think that's just a decrement. So we could just replace that with a minus, but we'll just leave it exactly as is, because our goal is I want to port it over exactly as is and then figure out what's going on here. So that's a call and a ret. Okay, now we're at 6070. Okay. And 6070 is push register 0 on the stack. I don't know what that means. I don't know how we're going to port that yet. I don't know what that means. Register 1 equals 32,769. Register 1 plus 32,767. So this again is decrement by 1. Okay. The decrement won't wrap properly, so don't change it. Not advice from me who made that error. What do you mean it won't wrap properly? How would it not wrap properly? Why wouldn't it wrap properly? It should. we add this big number to it and then we mod by 32,768. You don't have 15-bit, right, but that's why I'm doing this mod by 32,768 here. Oh, sorry. You're saying the decrement operation, the decrement, using the minus. Right, okay, I got you, yeah. Oh, you ran into that, dude? That sucks. You were getting numbers like 65,500 or whatever. Oh, that sucks, thank you, because if I tried to optimize it, I would have totally messed up. If I make it a short, it will wrap. Yeah, oh man. I would have done that too. I would have absolutely made that mistake because in my brain, I'm like, oh yeah, short, 32,000. Like I just start forgetting signed and unsigned in 15-bit address space. Oh man. Okay, what are we doing now? 6070. Push R0 onto the stack. Don't know what that means. This is 6072. Okay, cool. This is 6076, which is call. And then we do more stuff below it. Interesting. Okay. Also glad to see you mod by 32,768 and not 32,767 like some me I know. Oh, that hurts. That hurts to read. That's so funny. 6078. R1 equals R0. 6081 pop. Don't know what that means yet. 6083 is R0 equals R0 plus 32,767 mod 32,768 decrement by 1. Okay. This one is 6087, which is call, so function 6049. I have some ideas here, and then return. And so that's just an implicit return, but we'll put it there. In fact, we probably should do that here. Oh, we do that here. 6052, where's the return get called? 6056, okay. Here's some nice annotated code. Look at that. Beautiful. Beautiful. Let's see. What's up, boss gang? How you doing? Hi, maybe this is OOT? Maybe this is Ocarina of Time. Okay, I'll assume you're talking about the video game for the Nintendo 64. I think you mean off topic. But I kind of want to ask you why some people really hate Rust. Listen, that is a great question. I don't know. I don't quite get it. I don't really, it seems like there's some drama sphere around it, so I try to stay away from that stuff, especially when I'm just like dealing with content on the internet. I hate engaging in drama. It gets numbers, but it gets like the worst people commenting. I don't know the answer to that. I like Rust. I think it's really cool. But I don't know. I truly don't know the answer. Ocarina of Time mentioned, dude, Ocarina of Time's great. I love Zelda. He's my favorite green guy. Dude, that's so true. What was that one thing? If Zelda were a boy, he could date Meteoroid. Incredible. Incredible. Glad I'm not the only one that reads OOT as Ocarina of Time. Dude, I can't. OOT, MM, all those stupid acronyms. My brain has just been broken. Push and pop is not just saving and restoring register values, maybe some array or temporary variables. Yeah, I got to figure out how I want to implement that. Because we don't have to implement a stack. We have a call stack. We have functions because we're in C, so I can just make those arguments. I think is sufficient. So let's figure that out now. Push R0 onto the stack before we mess with it. So that means keep R0 the same. And then we restore it here And then we call this function again. What the heck does this function even do? So let me back out of there. Let me go to the cargo run real quick. And let's not do the disassembly. Let's do this. So this is the main program. And what I can do is I can dump my state here. So I can see that when we get to the point where we're about to use the teleporter, these are the values of our registers. So we know that. We know the values of our register are 25989, 25988. That's really good. But if we look at my notes, we can see that this function gets called with this 5511, so 5505. So let's do the disassembly again. Let's try to go there. 5505, yeah. So something about the way my RAM is set up, we literally just we are just setting register 0 to 4 and register 1 to 1. I don't know why, but that's what we're doing. So 0 is 4, 1 is 1. So we could literally just do that here. 0 is 4, 1 is 1, and 7 is... no. uint 16 underbar t r7 equals 1, because that's where we're going to test it with. Now, okay, I have to think about this. I started learning Rust a few weeks ago by going through Learn Rust book online. I've been really liking it. Hey, that's how I learned, or maybe I don't remember which one it was. It was like the Rust book. I think Steve Klabanak is the author of that, and members of the community and stuff. That's how I learned it. But yeah, it's a ton of fun. It's a great language. I love it. I think it's really cool. As I'm, primarily writing Bash on my channel and currently writing C, but I love Rust. It's a great language. Oh, T means out of topic. Yeah, no, it means Ocarina of Time. Sorry. Rapid. Hey, Dave. Hope you had a nice Christmas. I did have a nice Christmas. Thank you. What a nice thing to say. I hope you did as well. Nice, that's awesome. All right, what are we doing here? So if we make these variables global, I'm trying to think, because should they be global or should we be storing them somewhere? I don't quite know. Push R0 onto the stack. Do we just want a stack? Bad Cop, are you around? How did you do this? Did you use arguments like local variables here, or did you implement some sort of stack outside of this? Like, because I'm trying to think of how to push R0 onto the stack. Because you have a stack. You talking about just my call stack? You talking about just passing in as arguments there? Trying to figure out what I'd have to do to make that work. I think I'm overthinking this. But okay. I thought about doing that. I thought about doing this, like uint 16t temp equals R0. And then when I go down here, I pop that off. But I don't think that's right. Because when you call this function, no, that does work. You're right, that does work. I was thinking, because I'm imagining like if we branch into this function and then two things pop off the stack, but you can't. That wouldn't make sense for that to happen. Yeah, because we're only ever calling the function once between pushing and popping. Yeah, you're right. I overcomplicated that. Yeah, okay. I think this is right. Right? So I think this is right. I mean, this part's wrong. For uint 16t I equals 0. Nope, I equals 1 because 0 brings us to Synacor. I less than 32, 7, 68. I plus plus. Don't use the double parenthesis. Wow, I've been writing bash for too long. Printf. Trying to solve R7 equals yeah. I think that's it, right? Yeah, it would be very bad there, yes. I think this is what we want. I did a stack because I was worried I would lose something in translation, but totally not necessary. I really thought that too. And if we were calling the function twice, like if we were push on the stack and call the function twice and then pop off the stack, I think that's a very real possibility. But because we're only ever calling the function once, I think we're always going to be safe in this situation. This is gonna be something. Okay. We initialize our values here. All right, 6049. Okay, we got some nice errors here. Nice, nice. Oh yeah, where we recall ourselves. What? Can't do this? Sure. Okay. Because of that decrementing logic, because of the decrementing logic, is it going to get slower as it goes up? Yeah. It's going to get slower as it goes up. Also, wait. Am I stupid? Hold on. What are we checking here? What? Hold on, I didn't think about this. What is what's the wind condition here? what even, like, what is even the win condition here? I just implemented a bunch of code. What does it even mean? How do we know when it's good? I don't even know what the win condition is. Oh yeah, no, things are going good here. What is the win condition here? Oh my god, if it's going that fast, you think something's wrong? Oh great. Okay, well that's good to know. What does call do? Call pushes the stack. No, hold on. Write the address of the next instruction to the stack and jump to A. It's about the friends you make along the way, dude. It totally is. Right. No, I know call and like I understand call and read. I'm just trying to remember exactly what it does. It takes the current thing, stores it onto the stack, and then it jumps us to whatever's in register A. And then when red is called, we grab it off the stack and we jump back there. So call is grabbing off the stack. So our win condition is like when we break out and jump somewhere else. But where is that? I don't know what I'm solving. Hold on. I have to, my brain's not, I gotta lock in. Because every time we call, that means we're jumping somewhere. I assume we're jumping to 6049, but we're actually jumping to whatever is on, whatever's in register A. The hell's in register A here? Call take, yeah. My disassembly needs that. Yeah. Yeah, write the address of the next instruction to the stack and jump to A. So whatever's stored in A. So A equals, and it's going to be a register? No. How do we get here? I don't understand. Oh, awesome. Yeah, because this doesn't actually recall itself. Is this our win condition? When R0 is 0? We set R0 to whatever R1 was plus 1. Also, yeah, let's make sure we do that everywhere. I think this is our win condition, isn't it? Because this is where we don't get put into another loop of calling. Who called 6049 in the first place? That's a great question, because I guess, yeah, okay, when you get back to whoever called 6049, that will tell us what they check. Hey, look at this. Okay, if register 0 equals 6, okay. Register 0 equals 6. That puts the answer in register A, which I didn't put in my disassembly. Okay, so we check if register 1 is equal to, or no, we store the answer. Okay. I can't think. If register 0 is equal to 6, we store that answer in 32769, then we conditionally jump based on that. So if that register is equal to 0, then we jump to 5601, meaning that it was false. Otherwise, the thing that we do down here is all the good work that we do. Dude, I don't know. I don't know what I'm trying to say. Long story short, we need register 1. Register 0 needs to be 6. That's our win condition, is when register 1 equals 6. So if I'm not mistaken, what was I doing? Okay, so this function returns a uint 16 under bar t. We'll call it value. If value equal 6, then printf. It worked. I think. Dude, I don't know. Wait, hold on. Why did I run that? That means that what equal 32769 is 7. Register 0 is equal to 6. That's all we're checking, if register 0 is equal to 6. So wait, what? Hold on. I'm so confused. Hold on. Yeah. We call it, and then we check register 0 after we're done calling it. So register 0 gets modified all around being called it. Do we have to store that variable somewhere? Like what? Like at some point, this is going to exit. Do we just return R0 all the time, every time we're called? Like that doesn't seem right. And what is the point of this function? What are even the points of these functions? I don't know. I'm using local variables for the registers. Yeah, I don't think I want to be doing that. I think that's my problem. I don't think I want to be using local variables. I think I want to be using global variables so I can check them at the end. Yeah, because none of these are like having an effect. Like, what's the point of this? Yeah, this isn't right. Yeah, I'm not going to refactor things. We're going to do this. I can't remember which one it was. R0. Okay. Yeah, I think that's right. You would end up refactoring things. Listen, true. Oh. There we go. Okay. So that doesn't seem right. And nothing printed it worked. So something isn't right here. Exactly. Instant, dude, we're done. Yeah, I'll be taking my job at Synacor now. So what's happening here? Yeah, so something, call me crazy. Something's not working here. Like, that's just not right. Nothing's being, like, optimized away, right? That doesn't make sense. Yeah, so, like, that's not being called enough times. Every iteration of the function values on R0 and R1 are different, right? Oh, they might be. No. No, they're not. Hold on. I don't remember what I was doing. Hold on. If you declare an end, but you don't set to 0, is it 0? Depends where I declared. If I declare it globally, like up here, it should be. Also, I do set them here but I don't know if you're talking about a different int somewhere. Oh, well, this would be a problem. Oh, that's not the right one. Okay, that was my problem. I was declaring R7 locally as well, so it was shadowing the global variable. Hey, bad cops, does this seem more like the speed you would expect? Oh boy, okay. Well, we have a function. We have a win condition. This seems right. We have a function. We have a win condition. Oh, good. So you and Bob both think this looks appropriate. So I'm on the right track here. So now we have to make this faster. Like, I don't even know what this function's do. What's the math happening here? Grok, explain this function to me. And give me another root beer while you're at it. Oh boy, I do have a headache. Oh, okay. What do I want? Am I hungry? I'm always hungry. That's my secret. You joke, but I ended up doing that. What'd you end up doing? Get Grok to get you? Did you use AI? Is that what you're saying? Oh, bad cop, I hate you. Or did you get a root beer? I tried to optimize and failed until ChatGPT explained the algorithm. Bad cop, get out of here. We don't do that here. All right. You do that on your own. Well, I guess you did do that on your own stream. Okay, you're fine. Ugh. Trash. All right, let's figure out what this algorithm's doing. Like, what even is the algorithm here? So the algorithm here is... it recognized from my C code that I was doing Synacor. It should. I wonder if it was like, if that's in its training data. 4, 1, and nothing. Stew squared immediately recognized the function. What? Oh, I could turn on optimizations on MBB. That's a very true thing. Stew squared immediately recognized the function. So there's a couple things we could do here, guys. I don't know what they are yet, but there's definitely a couple things we could do. Or like multi-core, multi-threaded. It's a famous function. Oh, okay, how fun. I'm not a nerd. Dude, I'm not a math guy. If he's a math guy, that makes sense. Dude, it's mad slow. And I think it gets slower as it goes up, doesn't it? I would imagine it does. I don't know. I'm going to go grab something to drink. I'll be right back. Bad cop. I think about that. Sometimes when Eric does these puzzles, like, I don't think it can't be random. It has to be like higher than you would expect. Because like, imagine if you just accidentally got the answer that fast. Like that would ruin it. That's awesome. That's so recursive. It just blows up the call stack. How fun. So yeah, we'll have to figure this out. This will be a lot of fun. Thank you, Becca. This is so stupid. We can't give up now, guys. We're so close. This feels like I'm doing Advent of Code. Right now, it feels like I'm doing Advent of Code, where it's time to take a function that sucks and make it suck a little less. I'll walk you through my thought process here. My thought process is to take no time to try and understand the math and just start throwing caches at the problem. Probably not the right way to do it, but that's what I'm thinking. Oh boy. Okay. We're gonna throw money at the problem. Actually, I called up Eric and I was like, bro, I'm gonna slide you a quick $100 bill. Like, let me know the answer. AWS credits. Okay. So we interpreted that differently. Dude, I don't know what this code does. Screw this code. All right, let's try and understand this code, like from a stupid person's perspective. Also, my mom made pizzelles. Oh my god, they're so good. I'm not gonna mute while I eat. What is even happening in this function? Like, what is happening in this function? Let's rewrite it. So now we have the better version of the function. And if R0 equals 0, that's great. If it's equal to 0, then R0 equals R1 plus 1. This is, I don't intend this to run, so we're not going to do the mod 360, whatever. Okay. Okay. If R1 is 0, I should have given it a V2. That's so true. Then we do R0 minus minus. This is not going to run. I don't intend this to run. This is just so we can see what's going on here. We're doing some bizarro stuff here in this function. Sure. Yeah, why not? Now that makes sense that in this case we call it once, but in the other case we call it twice. I'm trying to see if I can just rewrite this in a way where my brain can understand it. Okay. Here's my hint in meme form. Oh man, I'm excited for this. What's the hint? Go back to school and study math? Lifetimes. I have yet to understand how that's a hint. I don't get it, but that's okay. I don't need to understand all hints right away because I've got a problem solve here. Oh my god, I gotta stop eating at my desk. That's a dumb move. I don't know if I'm using that word correctly. Oh, what a great hint then. Bob, you think if I rewrite it with locals and return values, it might make it clear? Yeah, probably. Here's a big hint from Eric. Oh, it's definitely a hint from Eric. It's a Topaz GitHub paste thing where you like base 64 and code it. What did you just send me? What is this? Okay, let's look at the big hint from Eric, guys. Incredible. Thank you. Thank you, Eric. I feel like you're here with me in spirit. Okay, we got this. We got this. Lock in. Lock in. Here's the formula. The formula. Okay, I've replaced R0 with A, R1 with B, and R7 with C, just to hopefully make this easier. I think that's what I meant by lifetimes. Okay, interesting. Okay, if A is not set to anything, then we initialize it to B. We have these two numbers we're playing around with, A and B. We initialize it to B plus 1, if it's not set to anything. Otherwise, if B isn't set to anything, but A is set to something, then we steal one from A, set B equal to the number that we're looking for. Okay, okay. I like the way I said that. Let me think about this. Otherwise, we store our A, and then we check again with the B counter subtracted with 1. So we subtract 1 from the B counter here. And then if that didn't work, or did work because we're not checking return values. We just keep doing things. Yes, assume A, B, and C are global variables in this case. So whether that worked or not, we're still going to go here. We're going to reset B to be our... What the hell? Set B to whatever A is at the end of that. Brother, what? What do we... What? Okay. See, this just scares me because, like, in this case, like, this could modify A. It could modify B. I don't know. This sucks. Temp equals A. We subtract 1 from B. We subtract 1 from B, and we try again. And then we get down here, we set B is equal to whatever A is. But A could have been modified here. When is it safe to make a global or local? Like in an abstract sense, is there an easy way we can tell if it's safe to make a global or local? I mean, probably. Hold on, I'm not there yet. A equals old A before trying minus 1. Then it calls itself again. I kind of like, I low-key kind of get, like I low-key kind of get what's going on here. Like, if we just look at this branch here, all this thing, if we have A and B here, they're both values. We decrement B, and then we run the function again, and then we go back, we reset B, and then we decrement A, and we try that whole function again. So, like, all this is doing is, like, if you view them as two big numbers, like a 7 and a 9, like, we have a 6 and a 9, and we try it. And then we go back to 7 and 9, now we have 7 and 8, and we try it. Whatever it is. Like, we're basically running out the clock here until we get to the state where we're done, which is this state. Our done state is when A equals 0, because then we won't call the function again. We won't recurse into it. So... our done state is here is when A equals 0. Because if B gets to 0, then we just decrement 1 from A, and we set B back to our starting number of that, and we just keep going again. Like, this is a painfully inefficient function. So what is it doing? It's always starting with the same two numbers, if I understand it correctly. It's always starting with 4 and 1. So our stopping condition is when A, which is 4, becomes 0. And our answer, because that's the thing we look at when we're done, is whatever B was set to plus 1. Now, when B is equal to 0, we decrement A here. But then we keep doing more work with B. So only when B gets all the way down to 0 do we take away from A. But we also take away from A here. We store A. And we decrement it once here. So what does that mean? But then this can get really down there. The only way this function ever returns is if A gets to 0. If I were to rewrite these to be local variables and return values, how would I do that? What would I even try to do? Because A is equal to 0. If A is equal to 0, then B plus 1. You know what this looks like? It looks like a tree structure, like a tree that goes left and right, like because you have 2 numbers and you decrement one and you try out some stuff and then you decrement the other. So it's like you go left side, right side type of thing. Like this is like, let's go the left side, and then this one down here is like, let's go the right side. But like these functions have side effects. That's what makes it so complex. And if A is equal to 0, then we have no more left side to go. And if B is equal to 0, I don't know what this is. Huh. I don't know how to do this. Let me think. I guess let's look at all the mutations here. So like mutate A. So if A is equal to 0, then we can mutate it. So if we could return from the function, we could just return a new A value. Here we mutate A, set B, mutate B, set B, mutate A. So it is. They are the same thing. I'm trying to understand all the operations that are happening here. But I mean, the reason the differentiation doesn't matter. It's just for my own brain. Mutate means that we're taking A and... Nah, yeah, it doesn't even matter. I don't know. Whatever, it doesn't matter. Those are both rights, but where do we read? If you don't read after you recurse, you don't care if it gets overwritten. That is true. But I'm not even... Yeah, hold on, I'm not even there. Well, we have to return... If we're going to use all local variables, I don't know if... whatever, I'm going to talk out loud. We're going to have to return A. We definitely care about A, which is R0. Because R0 is the thing we check here. Like, we definitely care about R0. We have, no matter what, we have to extract that value out of it. It's like this thing would have to... I'm imagining it has to return A somewhere. Like, if it were like this, uint 16t... It would have to like return A somewhere, like. But then what happened? What is this? Oh, because that's A. Oh, I see. Okay, well, hold on. Yeah, we return A here. If B equals 0, we do A minus minus, B equals C, and then we call that with AB modified here. It's happening. It's happening. Yeah, we're getting here. We're getting there. I'll have to rewrite it with the code below, just because I don't handle the decrementing and stuff super well. Please remove b equals a. It's scaring me. Okay, I think that's it. Let me do this in the real function now. What's up, Kate678 official? It's amazing what you do. What I'm doing right now, completely failing at coding. Thank you. No, I appreciate that. What a nice thing to say. That's a super nice compliment. All right, so here we go. You the man. Yo, what's up? Thank you. What a nice compliment. You guys are too kind. No, but seriously, thank you. That's awesome. I like to think I'm the man, you know. All right, what do we got here? If this is equal to 0, then we are done. We just return R0 here. If R1 is equal to 0, then we do some mathematical calculations on it. And then we call this with R1, R0, R1, and R7. And we just return that. And then if we get down here, then we say temp equals R0. We modify R1. We call this with R0, R1, and R7. Yep, that looks right. And then we say R0 equals this. R1 equals R0, R0 equals temp, 0 equals this. I think that's right. You can just set R1. I could. Yeah, this one. I could. I probably should. I'm trying to keep it looking like the disassembly, but there's probably no reason to do that. Still going to be slow, but at least I can reason about this a little bit differently now. I can't quit until we get R7 equals 6. Okay. Now we have a pure function. And you know what that means? When we have a function where we know what the inputs are and what the output should be, I know what we can do. All right. Let's have some fun. This beat is sick. No, God, stop. Stop. Okay. Let's vim 6409.rs. You guys ready? There we go. So now we can do this. We can do... there we go. It's so annoying because Eric probably had this as a starting point. Yeah. That is true, which is really funny to think about. I would love to see some behind the scenes on this. I don't know if he's given a talk on it. He's done some Advent of code behind the scenes, but I would love to see the thought process and work that went into this. And did people get different challenge binaries with this? I don't actually know the answer to that. Like, because we're using aneurysms and there are, like, you know, hard-coded codes there. Did people get different codes? Yeah, I want to know. I'm very curious. He only jumps in my chats around Advent of Code, though. I mean, it's the holidays, probably busy, but still. I think there were multiple binaries. Someone in my chat had different flags. Oh, okay, cool. Awesome. I've seen a repo with different codes. Okay, yeah, so that makes sense. I could see him doing that. For I in, what was it? 1 ... 32 768. Print line. Trying to solve R7 equals that. Okay. R0 is a U16, R1 is a U16, and R7 is a U16, and it returns a U16. Okay. That's fun. Okay. What language do you think is better, C++ or Rust? I don't know any C++, so don't ask me about that. I'm going to say Rust no matter what. I am not comfortable with C++. I would need someone like Bad Cop to weigh in there. Dark Space if he was here. Okay. What other languages do you know besides Rust and Bash? I would say Rust, Bash, and C are probably my top 3. I know JavaScript decently well, but yeah, these are definitely like my top 3 languages. Bin 6409. Unnecessary, not found in the scope, not found in the scope, not found in the scope. What do you mean not found in the scope? Oh, probably because I wrote 6049. When did it become Rust? The more I look into C++, the worse it looks. I think I'd rather write everything from C from scratch. Yeah, I mean, I can definitely understand that opinion. I mean, that's kind of where I am, but I've seen some cool stuff with C++, so I can't blindly hate it. Yeah. Listen, it just became Rust when it became Rust. That's all I can say. You went to... Okay, yeah, so we went to the languages we're comfortable with, because I want to start adding some caching, and I just don't feel like adding my own data structures to this. So... you know, I can give it a cache now. So we can just use standard collections, hash, map, caching. Exactly. Dynamically growing things, I just didn't want to have to deal with that. So that's why I stayed away from it. What's our cache type? Type cache will be a hash map of a tuple of a U16 and a U16. And that will be a U16, won't it? Yes, it will. I think that's the right syntax for it, right? So this will take a cache mut cache of a cache, and this will be a let cache equals cache new, and it will take it there. Let's do that. Hey, I just bought the Bash course. I want to support releasing stuff for free and optionally being able to support it. I love the Bash course. Thank you. Thank you. What a nice thing to say. I love that. I'm so happy for you. For anyone just tuning in, I have a Bash course available. It's on YouTube. It's a completely free video. You don't have to pay for it. But if you want to, you can. I believe in giving away educational content for free. I'm not against people who sell things and make money. Hey, I like selling things and making money too. I wanted to give this away for free. I didn't want to paywall the content. I thought it'd be fun just to release it and give it away. But you can pay for it if you want. So it's $10 USD. You get the DRM free MP4 download, or name your own price. I really don't care. Anything you want to spend on it is totally cool with me. And I like it that way because then I feel good about it. When people buy it, it's because, like this person just said, it's because they want to support it. They feel good about it. You know, there's some students out there that don't have the money for it, and that's great. You don't have to pay for it. Like if I was a student, if I was just learning, I probably wouldn't be able to buy something like this. But if you're in a place where you can afford it, or, you know, you got that adult money now, or whatever you want to say, like, I appreciate it. So thank you. I appreciate you buying the Bash course like that. I appreciate anyone who bought the Bash course. And if you don't want to pay me, you don't have to. Don't worry. It's completely free. It's on YouTube. So. All right, let's do this. What are we doing here? Oh, right, I gotta keep passing the cache along with it. Oh, we're not passing a mut cache. No, we're passing a mutable reference to the cache. There we go. Also, we could parallelize this, but that, you know, whatever. Okay. Everything else is gonna just error out. Who cares? Let's see. Oh wait, I didn't actually use the cache. I just added the overhead of passing a mutable reference around. I didn't actually use the cache. That's so funny. Okay. Oh my god. What do we do? If let some v equals cache dot get R0, R1, and R7, then return v, else we'll cache it manually. Let v equals this, cache dot insert v, return v. Let's just make sure that works before we continue. What's happening here? Expected a tuple with 2 elements, found one with 3. Oh, we're not caching R7. There's no reason to do that. Can't be dereferenced. Consider dereferencing the borrow. Can't be dereferenced. Okay. There we go. I just want to put the cache check at the top, but that seems unnecessary. We're just going to be duplicating code here. There we go. Okay. Now we can say R0 equals if let sum v equals cache dot get R0 R1. Then we'll just return that. Otherwise, then we go through this whole song and dance. It's probably a way to write this a little bit cleaner where we don't have to just keep duplicating this code like this, but you know, here we are. There we go. I think this will work. I see magic numbers. What's up with those? Oof, I don't even know if I can explain them. We're so deep into it at this point. This needs a semicolon. Okay. That seems a lot faster. We're at 1,000. We have to get to what? 32,000? We're caching per number. We're caching per number. I think the cache could technically have everything in it. Let me, because this will solve in a decent amount of time, but let me do something else. Also, are we running? Oh, we are running with release. Okay. I do think that because the way we've written this, we can just maintain the cache the entire time and just put the cache here. And I think this will run way faster. That ran way faster. Now, none of them were right, so maybe we can't do what I just said there. I actually don't know why they're not right. Because who cares that we pulled that number out of there? Like, who cares? That should be fine. So none of them worked? You had it right. You'd have to put R7 in the cache key. That's what. Oh, I didn't think that it would matter. Like, if R7 was 20 or R7 was 40, like, the logic should still be the same. I don't think it should make a difference, but I could just be wrong here. So let's just put the cache in here. And yeah, let's do this. Let's print line and print line. Let's print line this if it worked, and then we can just write standard error to log.txt. Yeah, because like, okay, like if we don't include R7 in the cache key and we use the same cache, like I feel like it should work. I'm worried that this isn't going to get any